Hello and welcome to Office Hours with Bill Jennings from Klamath Community College. In this episode, we're going to talk about solving equations that are quadratic in form. So it might not be something we immediately look at and see it as being a quadratic equation, but with one small little substitution, maybe we can make it look like a quadratic, solve the equation, and then resubstitute back. So something for us to potentially look at would be looking at this equation right here. So we look at 2x to the 2/3 plus 7x to the 1/3 minus 15 equals 0. Now that looks like a rational exponents problem, but I'm going to have a hard time isolating that individual rational exponent to make it go away. But maybe with just a little bit of a look, it could be potentially seen as being quadratic in form. Now the kinds of things that we want to look at to be quadratic in form is that this variable here squared must match that variable exactly. So remember what a quadratic might look like. If I had a quadratic that was x squared minus x minus 6 equals 0, we would identify that as a quadratic equation. And the thing to note is that this is x and that is x squared. So quadratic in form, again, looking right back over here, if we have that x to the 1/3, when we square that, we'd get x to the 2/3. Looking over here, quadratic in form, that's x to the -1. X to the -1 squared would produce x to the -2. Looking at the other two examples I have picked out for us, quadratic in form again, that middle term, I need to be able to look at that square root of x and say what would happen if I squared that. I would get x, and that's actually the variable that's laying here. And again, one last time, if I have x squared here, I can see that as becoming x to the 4th if I was to square that. So now that we've identified what quadratic in form looks like, let's talk about how we can substitute and make that come together. So now that we've identified that we have something that's quadratic in form, I need to talk about this substitution method. Now some people call it a U substitution and some people have called it a T substitution. I've seen it both ways, so you could really go either way. So if we were to look at a T variable substitution, if we were to choose this middle variable that we have to be our T, if I said t equals x to the 1/3, I could then say that this is 7t and the 15 is just going to be what it is. Now we recognize the quadratic in form as being that middle term, if I was to take that and square it, it got the other side to be what I wanted. So is it fair to say then that t squared would be the same thing as x to the 2/3? And so my substitution is that I've got this x to the 2/3, which is right here, so I can just call that t. So this becomes 2t squared plus 7t minus 15 equals 0. It's a t substitution to get it into a perfect quadratic. So it's quadratic in form. A substitution is made. I've now created a quadratic equation that is very solvable. I could use the quadratic formula, I could use factoring, I can use all those quadratic methods that are available to me, completing the square. In this case, I'm going to hope it factors because that's the easiest one to do. So let's see if we can factor this and make it come out to what we want. Looks like that's going to be a 2 times a 10. I need to get a 10 and then a minus 3. So let's make it plus 5 and a minus 3. It looks like that's going to work out for me. Checking it in my head, looks like that's the right factored form. So now in this it's now quadratic equation. I'm solving for t, so now I know that 2t minus 3 equals 0, and I also know that t plus 5 equals 0. Minusing 5 from both sides, that means that t equals 5. And over here with the subtraction, subtract 3 and then divide by 2, I'm going to say that t equals 3/2. Now, the original question didn't ask me to solve for t, it asked me to solve for x, but I used the t substitution to get me going, and so I need to substitute back. Now, the common mistake here that happens is that what people will do is they'll substitute back in here this one time and then that one time. How much is a t worth? Originally, we stated that t was x to the 1/3. So I'm going to substitute back to my x variable and say, well, t was x to the 1/3. So that means that x to the 1/3 equals 3/2. And right here, that also means x to the 1/3 equals 5. And then just finishing the problem up, it's a 1/3, so I up it to the third power, and so that's going to be, x is going to be, oops, that's a 27. Let's get rid of that. I was doing the bottom instead of the top. I got 27/8, and in this case, x is going to be 125. Now, while it would be a good idea to check my answer, I don't have to legally, because this was, I powered it up to the third power, so I didn't introduce any extraneous solutions. Checking my answer would be a good idea. So what we identified was quadratic in form, t substitution, did the substitution, and off we ran. Let's look at another problem so we can get one more piece of practice in here. So x to the -2, x to the -1, and a 6. So if I could identify that, hey, this is quadratic in form, and if I let t equal x to the -1, then I could say that t squared equals x to the -2. Simply, what is t squared? X to the -1 squared is how that's going to work out. So this becomes t squared minus t minus 6 equals 0. Let's not overthink what's happening here. X to the -1 was established to be t. So everywhere I see an x to the -1, I'm going to write t. X to the -2 was established to be t squared. So if I see an x to the -2, I'm going to write a t squared. That's my substitution moment. Now, I went from being quadratic in form to actually being a quadratic with the variable t instead of the variable x. Where this can factor, this is going to be t minus 3, t plus 2, and that equals 0 in my factored state. Nice when things factor nice and clean. So t equals 3, t equals -2. We weren't asked to find t, we were asked to find x. Now, at my original statement right up here, I said t equals x to the -1. So I need to substitute this right back into here. So that means x to the -1 equals 3. Well, that's really 1 over x equals 3. So in order to solve that out, x is going to be equal to 1/3. Now, over here on the other side, again, we said from the very beginning t equals x to the -1. So when I see the t, I can substitute back in x to the -1. X to the -1 equals -2. Don't confuse negative exponents to meaning that you have a negative canceling out here. This is t to the x to the -1 means 1 over x equals -2, which in this case means that x equals a -1/2. Now the negative came from this side, not the negative exponent. So let's take a look at my other two examples that I had set up. One more time, I had this variable right here being the good t. So t equals the square root of x. If I took t and squared it, I would get x, because the square root of x squared is just simply x. So I can substitute that in, creating 2t squared. Now notice this was just an x, but it became a t squared because x takes on the value of t squared. So 2t squared minus 7t minus 30 equals 0. Some of my factorings may be getting just a little bit tougher, but we should come out of this okay. So then we can factor this one out, and I think if we end up with a 2t plus 5 and a t minus 6, I think we come out okay. 12 and 5, that's 7, equals 0. So at the end, we end up with 2t plus 5 equals 0, t minus 6 equals 0. Let's give ourselves a little bit more room here. Now, we need to solve for t, so we end up with 2t equals a -5, t equals a -5/2. Again, we didn't want to know what t equals, we wanted to know what x equals. Now, the original substitution for t was t equals the square root of x. Many students struggling, whatever reason, want to stuff it right in here, but it's not where it goes. It is this guy right here. So t is the square root of x, so that is the square root of x equals a -5/2. Now it's time to square both sides. and x is going to be equal to 25/4. Now, because I'm paying attention, I'm going to recognize that's actually an extraneous solution, because the square root of x is never going to be a -5/2 unless it's an imaginary number. So I already know that that number is going to get thrown. If I was to put this number in back up to the original, it will not check because of the absolute value problem. Then down here, this is going to become t equals 6, and again, t was not the value, the variable of choice. It was square root of x equals 6, and when I square both sides, I'm going to get x equals 36. Now I should plug that back in up here and double check and make sure that's a valid solution. And I have to do that because I squared both sides, which can introduce that extraneous solution. Let's finish up here with our last problem. I'm going to get rid of this. Is going to confuse us right here at that moment. So let's get rid of that. Clean this up. So again, it's quadratic in form. So focusing right here, x squared, and that squared will make x to the 4th. So t is going to be equal to x squared, meaning that if I squared both of those sides, t squared would be equal to x to the 4th. So taking on this value in quadratic nature, this is going to be 13t plus 36 equals 0. I hope that's factorable. I think I see a 9 and a 4, so t minus 9 and a t minus 4 equals 0. That means t equals 9. That means that t equals 4. Now, I didn't know what t was, but t actually took on the value of x squared. So right here, when I have the t, that's going to go back to x squared because of this right there. That's who a t was worth. So x squared equals 9, and then down here, this is going to be x squared equals 4. Again, it's x squared going to both places because that's what a t is worth. Now, solving this is a well, x squared equals 9. I need to use square root methods, so I'm going to square root both sides, and when I square root, I'll get a plus or minus on the right because it's on the side opposite of the variable. So x equals plus or minus 3 because that is the square root of 9. And over here, I'll get x equals plus or minus 2 because that is the square root of 4. We'll take the square root of both sides and with the plus or minus. Now, when we look here, this is a higher degree polynomial of degree 4. We should have expected 4 answers, and we got exactly 4 answers. We got a -3, a -2, we got 2, and we've got 3. So we ended up with all 4 of our answers. Thanks for tuning in. We'll catch you on the next video.